Well, I'm just going to Amherst, so we're not
Oh, really?
close.
Amherst is a great place.
It is very cool.
So you like Boston? You went there?
I went there a few times, you know. Yeah. I went when they had like 5 feet of snow, and they ran out of places to shove it. So like there were streets closed and just like piles of snow everywhere. It was really cold. But it was an experience.
Okay, good.
Well, it was never that long.
Yeah. I think that Portland, it sometimes does snow, but they're very unequipped for snow. Like they don't have snow plows and all that stuff. Yeah.
It is closer to Crater Lake, though.
Oh, do you like Crater Lake? It's great. That's another thing. That's a place which is undersold in general too. I think.
Yeah.
Have you ever been to Crater Lake, anyone? Oh yeah.
It's my favorite national park.
Yeah, exactly. My opinion is that the national parks which are closer to urban areas, like Yosemite, get most of the hype just because they're closer to people to get there. But Crater Lake, I think, is as good as any of them. You know.
Yeah. I mean, it has a little volcano on a lake and a bigger volcano.
Yeah, exactly. Right.
What more could you ask?
So beautiful. Yeah. It's like in Korea they have Baekdusan, you know. It's up in north. It's kind of like yeah. It's like the border of North Korea and China. It's like a similar kind of thing. It's a volcano and a lake inside. It's very similar. Yeah. Okay, I think it's going. So yeah. Another one which is really good is Olympia National Park.
That's what we're supposed to do.
Yeah, that's also good.
Good place for vampires always.
Twilight was so fun.
Yeah, it's beautiful.
There's so many little environments there.
They have beach and hot springs and
exactly.
rainforest and mountains. All in one national park.
Another one which is undersold is Channel Islands National Park. Have you been there?
No, that's really close.
That's very close to here.
Yeah.
Just take a boat.
That's San Harbor, right?
Yeah.
It's a national park.
It's a national park. Oh, yeah. You go there and it's like completely undeveloped.
Yeah.
You can take a boat there and hop around.
I just went to Grand Canyon during the break.
Oh, nice.
And it is not undersold.
Grand Canyon is nice.
It's really exciting.
Exactly.
What is it like? It's close to here. It's Antwerp Valley.
Oh yeah.
I've seen pictures and there's like really nice poppy season, orange flowers. But I don't know if you go now, you probably won't find it. Maybe you will this spring, but you probably have to go to certain counties. Probably find it.
Okay. You guys got that for a second. So where are we? We're talking about the company information, right? So it's like a big very good information. So it is smaller. Well, that's another minus of Chicago, by the way. It's not close to anything like that stuff. Chicago is not close to anything like that. And so we have model complete information. Remember, what is that thing? What is it called? What is the model complete information consist of? So, there's one thing which is the most important thing in some sense. So whenever you technically conditional, sorry. It's like, so what I mean is this is a model of include conditioning. Whenever you have a situation of incomplete information, the most basic thing is what? The most basic thing. So anytime you're in a situation of information, the most important thing is to specify. This is what makes it potentially specify.
I'm not sure if this is a probability space.
It's a probability space, but the most basic part of that is, I guess that's sort of good. But when anything is uncertain, the most basic thing you have to specify is what? And this is all. Yeah, the omega, exactly. The setup of, exactly, about all things can happen. So that's the set of states of the world. And that's the most basic thing. So you always have to specify that. And one of the reasons you have to specify kind of advances that people will often say things like this, like, I'm not sure about is it, do you have an equal reference or not? And then you might say, well, I'm not sure what your beliefs are. You might think I have equal reference, all those things are right. I'm not sure. So it could become a very complicated mathematical algorithm. And some people like to study that kind of thing where I have a belief which is like a number between 0 and 1. And you have agreed about that number, which is like a Pauli distribution 0, 1, and I have a Pauli distribution over that, here's a Pauli distribution, it's a little complicated. Much simpler to say is, I'm going to specify right from the beginning what all possible uncertainty is, right from the start, and I'm not going to keep doing this stuff. So that's a nice thing to have. So if you simplify it, people say, well, what if something else could happen? And then you say, well, you have to specify like, that should be another thing. So that's kind of how you got here. So Omega is the most important thing. It's a set of states of the world. All the things are true. Okay, and then we said the other things, right? It was this probability distribution. Okay. And this is just, remember it's going to be a little defined subnumber. This is this little p of omega. This is one state of the world. This is just how probable this is. Okay. I guess the probability distribution is going to be a function from omega to zero. When I write it this way, it means that P takes elements in omega, which is like this little omega thing to something to root. Okay, then we talked about, we introduced last time, how we represent information, how we represent knowledge. Yeah, exactly, with the partition. So there's this PL, right? Person, eyes, partition. I guess I'll call it a knowledge partition. So a partition is a set of subsets of omega, such that the union up to omega, and also there's no overlap. Okay, this is my model, and you can do stuff we did last time. Like we talked about events. An event is a subset of omega, right? And knowing an event, you can also think is an event in itself. So you can do all this stuff like, when do I know that you know that I know something? That's all very well nicely defined. Oh, I should have. There is this. This is a bit of an aside. Do you remember there was this thing, there was an internet meme of like, John knows that Barbara knows that Kathy knows their birthday or something, Cheryl's birthday, do you remember that? And you remember that? Okay, well, I'll talk about it. That stuff is this. You can solve these things in a very clear way. Okay, so this is my model of incomplete information. Now if I make a game with incomplete information, what do I have to add? Okay, so this is just a model, right? To make it a game, what do I have to add? Players, right? Exactly. So I have players. This is my players. What else?
Strategy?
Yeah, strategy, exactly. So we'll call it, this is person's eyes. I'm going to use the word choices because I'm going to use the word strategies in a second. Choices. Okay, so yeah, the choices. And then finally, what else? Payouts, exactly right. So when I teach PS30s, players access payouts, exactly right. That's what the world of game theory is. Players access payouts. That's like that's basically it. So here's payoff is represented by a function. Go from A to R. Have you seen this before? This is like a boldface R. This simply means the real numbers. Okay. This is a capital A. A is going to be this. So n, say n is going to be 1. So there's n players. What does this x mean? This simply means the cross product of those things. Have you seen that? In other words, so an element in A is just going to be like A1, A2. This is just a strategy profile, right? It's just a specification of each person's strategy. Okay, a person's utility function maps for every strategy profile. There's every specification of what each person does, and maps it to it. Okay, so this is I think this is it. Is there any more stuff you need to put? Okay, so this is it. This is what a game with incomplete information consists of. If you have a game without incomplete information, it's just these 3 things. Okay, but with incomplete information, you have that list. So it's like 6 things. Okay, so there's one thing which we have to consider, which is how does like this stuff interact with this stuff? Right, so how do I put all this framework into here? Okay, and it's very simple. Do you want to, well, I guess it's just two ideas. How is this information stuff going to matter to my game? How do I make it matter?
I think a person's expected payoff should be based on their partitions of
Yeah,
so
exactly right.
It's the set of partitions they recognize.
Exactly. So it'll be, so this is my payoff, right? But in an incomplete relational world, they'll have to have an expected payoff, right? It'll be summed up over things, right? So there'll be an expected payoff. Okay. But in addition, like basically kind of there's a, how would I get an expected payoff? Another way to think about it is, why do people care, in this world, why would people care about the set of states of the world?
The outcomes.
Yeah, the outcome, right? But why would you care about, why would you care about the outcome? And in other words, how do I represent it in here? So here, for example, I'm running this down, meaning I care about what I do when everyone else does, right? But in addition,
Could you explain that?
what does this mean?
R, the R.
Or is this the number?
Okay, no.
Just real numbers. That's the set of rules. So if you ever see a boldface R, sometimes you'll write down the two things. Okay, so here by writing this down, I'm saying my payoff depends on what I do, what everyone else does, and that's what gives me, so every one of those things I assign a real number to. But in addition, this is what I have to do. My payoff is going to depend on what else?
Choices.
Well, not only choices, but
The actions of everyone else.
the actions of everyone else, but also, yeah, it's going to have to depend on some of this stuff here. So the way we make that happen is to say, simply, your utility function does not only depend on what everyone else does, but it also depends on the state of the world. Okay, so it's like, if the state of the world is like I have nuclear weapons, then my attacking gives a different payoff than if I attack without nuclear weapons. Okay, so my utility depends on actions and the state of the world. So it's pretty simple. Okay, so that's the one idea. So the one way you put this framework into here is to say that your utility depends not just on your and everyone else's actions, but also the state of the world. The second idea, which will lead to this thing, is how do your choices now depend on things? So like, okay, you have some knowledge of the world, right? And then you're going to make a choice in this AI, okay? How does that choice depend, what does that choice depend on? I'm kind of trying to motivate it, but I'm sort of just reaching in some ways. I can just tell you, but it's a little more interesting to think about this.
Your knowledge.
Your knowledge of the world, right? Exactly. That's how this partition is going to matter, right? Okay, so what is another way to think about it is what is a strategy? Okay, and so a strategy say call it F and Y. It's actually going to depend on the state of the world. Okay, so it's not just one thing, right? It's like if I know whether I have nuclear weapons, I might do something differently if I have nuclear weapons than if I didn't. Yes. It's a function from the state of the world to what?
Some outcome.
No, so it's, I don't choose the outcome, but I do choose.
Your choice.
Yeah, exactly. This. Exactly, right? AI. So for example, AI might be attack or not. Omega might be, I have nuclear weapons, I don't, you have nuclear weapons, you don't, that stuff, right? Okay, so it goes from this to AI. Okay. So strategy is strategy. So this is why you use the term choices here to distinguish from strategy. Strategy is sometimes you use the word a contingent plan. It's a plan which depends on the contingencies, i.e. what you know about the world. Okay. All right. Now, this is interesting. It depends on omega, right? But how are we going to get these partitions to make, obviously we want these partitions to matter, right? Okay, so how is this thing going to depend on the partitions?
What are the colons again?
Oh, this colon? It's just
Yeah.
a way of saying I go from here to here.
Okay, but isn't that what the arrow is?
I guess so. I guess you could write it like that, but then it's like, what is the difference in if I
Okay.
It's like punctuation between.
No, sure.
Yeah, you're right. I mean, I guess
I
you could
see it
just-
all the time, and I just never quite.
Another way, sometimes you can run it like this.
Like in words, what is the?
Well, what does it mean?
So F, yeah. You just.
This is just, this function goes from this to this.
Okay, thanks.
That's all it is. I guess this is not pronounced in some sense. It's a little confusing because I guess we use this sometimes for such that, right? Like for example, you said like x
Yeah.
and y is such that, you know, x
Yeah.
is equal to 0 or something. Yeah, that's actually different. I never realized that.
Yeah.
But yeah, it's not really pronounced. Like, sometimes you see this. This is maybe a little better. This means that fi maps are maybe, this is actually cleaner kind of. Yeah,
They're equivalent.
they're equivalent. Another thing which is like that is like 6 minus 7 equals what? Negative 1, right? But why is this negative the same thing as this? There's no reason they have to be. It's actually kind of confusing. Right? There's no reason they have to. This could be like n or something like that, right? It's just actually confusing. So you have all these things where you have like 6 minus 3. It's like, what the heck? Strictly speaking, these are
Well,
different
that's
things.
why they raise the negative.
Oh yeah, exactly right. Somebody just said that exactly right.
Yeah.
But it's one of those things which they could have figured out ahead of time. And they didn't, so we're all stuck with it. The whole world is stuck with something which is not great. A lot of
That's
things
why we
like
should
that.
get rid of subtraction and just add.
Exactly.
Add by negative numbers.
Exactly. Well, okay, I have a, there are certain things I think I just looked at, like, I have to think about that, like, I think, for example, the way you teach Bayes' rule, I think is much better than the way most people teach Bayes' rule, so, like, I'm all about trying to make it as simple as possible. Anyway, yeah, so maybe this is better, this is way better. I can even do that from now on if I want to do that. Okay. Another thing like that is the electron. Do you know what I'm talking about? The electron has negative charge. So when we see currents is flowing in a different way, the electrons are actually flowing backwards. So like, why is current going the opposite way of electrons? Why is that? It's because Benjamin Franklin got it wrong at the beginning, and everyone is stuck with it. It's really not silly. That's all it is. Yeah. Okay. All right. The strategy is this. How does it depend on the partitions? And this is kind of this is the second key idea after thinking about it. It's almost the main idea, I guess. Okay, so.
It's based on what? Because the partition describes what you know about.
Yeah, exactly, right. So exactly, this should obviously depend, this thing should depend on PI in some way, or the partition in some way. Okay, how does it? Let's think of a simple example. Say that, I don't know.
Because it affects your expected payoffs.
It does affect your expected payoffs, but the main thing it
And also
affects
what
is,
you expect others to do.
well, kind of, yeah, but like, say that my partition is like this. Okay, my action is going, my strategy is going to be something which is sun. And say like, I don't know, say my action is either bring or not bring an umbrella. Okay. If my partition is like this. Okay, so could I play, is this a reasonable strategy for me to play?
So you can't do that when you partition, you can't draw a partition between sun and rain, right? Is that kind of the idea?
Yeah, exactly. So this means I can't tell between sun and rain, right?
So
What does this mean?
this means you won't bring an umbrella.
Yeah, I'll never bring an umbrella.
Yeah.
Right?
I mean, recently. Yeah.
So this is something you can play. Yeah, this is okay.
Yeah.
I mean, this just means, I don't know whether it's sunny or raining, so I'll just leave the house without an umbrella. I'll just take my chances. Makes sense?
Chances are pretty good here.
That would be the P, right? That would be like 0.9, 0.9. Yeah, exactly.
Also, you need a different strategy for different.
Yeah, exactly, right, exactly. That's kind of the idea.
Like in the incomplete dotted things, you only have one strategy.
Right, exactly, right. So this is possible, but what is not possible would be something like this. Right, you couldn't play that strategy if this is your partition. Does that make sense?
Because you wouldn't know.
Yeah, because you wouldn't know, right? If you don't know the difference between sun and rain, you can't play something different than sun and rain. That's all it is.
Not or bring.
Huh?
You can either both not or both bring in.
Yeah, exactly, right. So the idea is like, yeah, and there's a term for that, which is so-called, okay, so a strategy is called measurability. So a strategy is this, is a function fi for negative ai, okay, which is measurable with WRT is with respect to. This is just the definition of PI. What does this mean? If so P is some element of PI, so it's some bubble in PI, then omega prime are both in the P. That is, there's two states of the same bubble. Then Fi omega is Fi omega prime. Okay. What this means is that if two things are the same element of the bubble, they're in the same little bubble, you can't do something different. You have to do the same thing. Okay. So in other words, what that means is it means that if you don't know anything that is your bubble is the entire thing, you can just take one choice. That obviously makes sense, right? You can only either do it or not, or whatever. You can't vary. If your partition is extremely detailed, then you can vary whatever the heck you want, right? So remember what I said before. The game of information is just like, it's really the way to think about it is the game of incomplete conditioning. It is simply if you know more, then you can condition more. That's all it is. There's nothing more fancy than that. Okay. So that's kind of what we're doing. Let's see if we get this. Let's hope it's working. Okay, let's see. Now it's working, okay. All right. So, heck? It was working a second ago. Okay, all right, I'll just leave it. Just leave it like that.
Does that say AI tracking?
It is the AI tracking.
That makes me feel better about the future.
Exactly right.
Humanity.
Exactly right. Exactly.
Oh, wow.
It's kind of sad. Maybe there's like some sort of, packets going to some organization somewhere. Who knows? Okay.
It's just learning. You're gonna take it.
Yeah, exactly right. It's just a one big training
know
thing.
what success and failure.
Okay.
Well, now it's going. Oh my god.
Yeah, now it's
look at
going. Okay. I'm gonna put this.
Yeah, you're helping the defense industry, right?
Okay. All right. So how do I write this stuff? Okay. So a strategy is a contingent plan, a function for the states or roles of the choices, which is measurable with respect to your partition. Okay. So in this case, for example, partitions like this. This is not measurable, right? The bring and not bring. It has to be not or bring. However, if your prediction is like this, then could you play, is this a legitimate strategy? Is that a legitimate strategy? Sure. Okay, so that's it. That's really all there is to this entire topic is this thing. Once you have this set up, you just, write all this stuff down, realize that this is how the partitions affect your payoffs, and then like you were saying, is you do the expected payoffs. So let me do some examples of this. So, I'll show you kind of how it works. So, let's see. Uh-huh.
So, like in the tree game, you can only loop decision nodes with incomplete information
Right.
when they're exact same set of strategies.
Right.
Right? So does that apply here?
Oh, okay, so that is slightly complicated. So I was a little bit too strong when I said this is it.
Oh.
So like, if you do, it's true, we will do that next. Like, so, so let's say something like this. Like say this person 1 moves here, and person 2 moves here. So this is the situation. When I put this public here, it's exactly the same bubble as you here. person 2 doesn't know whether 1 did B or C. It will know whether 1 did A. So 2 has to choose either D. What 2 cannot do is D, E, right?
Right.
2 can't do something different. That's the same measurability thing. 2 has to play D.
You have to choose D or.
Yeah.
And they both have to be D or E.
Right.
Otherwise
So,
they would know where they are.
exactly, right. So if I had something like this, that would be not
Right.
kosher because this means that person 2 could have somehow figured it out or something. So the included information in the trees is a little more complicated. It's like a whole subject of it. So we'll do that. Okay. These are very common in bargaining, like crisis whatever, that kind of stuff and all that. Oh, another way to say it is that in these games with trees, the issue of like revealing something comes up. Like I can learn from something given your action. And here there's no revealing. It's just all straight up. There's something not known. You just play. There's not like I can figure out something about the world given what you do. Because it all just happens. So this is like, I guess you could speak the simultaneous game. Okay. Let's do the simple example. Okay, let's see. So this is obviously my umbrella example. Okay, so I'm going to say that there's 2 possibilities, sun and rain. Okay, and there's going to be 2 people. Okay, and person 1 and also person 2, they have the same thing. They can either bring or not. You can either bring or not bring the umbrella. Okay, let's see. And here specify 6 things. I already specified 3. The sun and rain, Tayar's actions. What did I specify? Partitions, right? I'm going to leave that last. How about P? I put probabilities. Probabilities are defined on well. It's a function on a neighborhood, so you just have to put like numbers and these, right? So I'll just do that. I think that's 4 partitions. What else do I do? The one's done, right? 16?
Okay.
Oh, utilities, okay, let's write this down. Okay, so I'm going to write that down in tablet form. So bring it up, I guess okay, so this is when the omega is sun, so the pair depends on your actions as well as the sun. What's going on here? It means that bringing an umbrella is costly. You just want to carry this umbrella around all day. It's -4. Okay. And if it's sunny, like, it's just a pure cost to bring the umbrella. If it's raining, however, so this is like you and your roommate. Okay? The only thing which is bad is if you and your roommate both don't bring an umbrella, then you both get wet. So this is like the chaos and getting wet. And I care more about being wet than you. Maybe I'll just got a haircut or something. Okay? And a nice suede jacket or something. So really what the best thing for you if it rains is for you to not bring the umbrella, the other person brings it. Because that way, they have to carry the umbrella all day and you get to be sheltered over you. Okay. I think I've specified everything. 1, 2, 3, 4, 5. And then finally we have the partitions, right? Okay, so let's do that. Let's just say that partitions. So this is going to be sun and rain.
So all that is you. So
Yeah, exactly. This is all you. Exactly. You is. Thank you. It's a function for what I do, what you do, and absolutely.
sure. United States of
Okay, so say that these are my partitions. What are my possible strategies? Okay, so strategy is a contingent plan. So from
Sun, bring, with rain.
yeah, exactly right. So how many strategies does this person want? 4, right? Exactly. So either bring or not for sun, bring or not for rain. Okay, so I'll write it down this way. I'll just write it as like B, 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 F, and B, F. Okay, and I'll even kind of keep it in the bubbles like this so you can see. Does that make sense? This is your strategy. Okay. How about person 2 strategies? What are those?
Same.
Same, exactly. Just the same thing.
Just stay home and no one.
Exactly. That's another action. Okay, so now what do? We just fill in this table in some sense. Okay, so this is something I first learned from a student. Say that I bring. So what does this mean? This is bring if sun, right? This is bring if rain. This is similarly sun. Okay. All right. So this means if it's sunny, we both bring. And therefore, what are our payoffs going to be? We're in this little state of the world, right? So it's what? Uniformness 4. So I'll write it down like this. That's what happens in that scenario. If we both bring and it's raining, okay, then we're over here, and what is it do we get? Similar to minus 4 minus 4. Okay. Now what's my expected payoff? -4, -4, right? I compute it by just doing half of this and half of this, right? This happens half the time, this happens half the time. That's where the p comes in. So just now -4 times a half plus -4 times a half. Okay, that's not too interesting. How about this one? If I'm here, I do sun. So when it's sunny, we're both bringing, right? So it's -4 -4. Now when it's raining, I bring and you don't, right? So it corresponds to what? So yeah, no, I bring it in -4 0. So it's for person 1, it's half of -4 plus half of -4. -4 -2, exactly. Okay. You can stop following me. Oh no, okay, all right. Okay, so let's just keep on doing. What goes in here? Bn, right? Which is, if it's sunny, I bring, you don't. So that's -4 0. If it's raining, I bring and you bring. It's raining. -4. This becomes what? I think that's similarly. Is it clear how I got that? This is half of 0 plus half of -1. Right? If the p were different, like this is Southern California, so it'll be 0 times 0.9, that's -4 times 0.1. Okay. But here this is Bn. This is -4 0, right? It's sunny and I bring and you don't. If it's raining, I bring and you don't. This is going to be what? Yeah, -4 0. And the expectation of all those things, expected values is
-4 0.
We're just going to do this. B is what? When it's sunny. It's -4 -4. And B, if it's raining, is what? 0 -4. And that all together is going to be what? 2 -4. BB when it's sunny is -4. And then when it's rainy is what? Yeah, this is the one where it's not. So that's express it one more. So this is going to be what? -8, -5, I think, right? Right, yeah. Half of -4 plus half of -6.
5.
Okay. Okay, Bn when it's, this is -4 0, I think. NB when it's raining is what? -4, this is -2. What's this? Bn is 0, and then this is at -12, -6 again. This is what? Okay, this is going to be, see this, it's asymmetric, so I have to actually compute it all. Can't take shortcuts. NB is what, 0 -4. BB is what, -4 -4. -2 -4, right? NB is 0 minus 4. Bn, this side is minus 4, 0. Minus 2, minus 2. Nn is what? 0, 0. Bb is minus 6. This is what? Minus 6 minus 3, right? Sorry? Yeah, I think so. Nn on sunny, it's 0, 0. Bn when it's rainy is minus 4, 0. Minus 2, 0. Almost done. Nb is 0 minus 4. And sunny when it's rainy, Nb is 0 minus 4. So 0. Nb when it's sunny is 0 minus 4. And then when it's rainy is minus 2, minus 6. Minus 6, minus 5, I think, right? I think so, yeah.
It's
Yeah.
9 and 6?
Is it 9?
Or 4, sorry,
Yeah, but yeah, 4 and 6, yeah, it's 5, yeah. Yeah. Nn is going to, sun is 0, 0. Nb is going to be what? 0 minus 4, 0 minus 2. And Nn and Nn, so Nn is 0, 0, Nn when it's rainy is minus 2, minus 6. This is going to be minus 6, minus 3. Okay, that's it. Makes sense? Super, super simple, okay? You just, this is my, you have the 6 elements, and I just create from this your strategy based on the predictions, right? And you just compute the expected utility. Now, how do I make a prediction in this game? Huh? Yeah, Nash Equilibrium. Now, why not? Just do whatever we're used to. So if I just do, what's the best response here? Person, I guess this is the first time we're actually doing a Nash Equilibrium class. Right? Yeah.
Okay.
So if person 2 does this, what's one's best response?
It's not,
Yeah, 0. And then if person 2 does this, what's one's best response?
not, but it's -2.
Yeah, it's just -2, right?
Yeah.
Okay. Person 2
0.
does this is 0. Person 2 does this,
-2
2. Person 1 does this, the best response is
is 0.
person 2 does this, person 1 does the best response.
-2,
Okay. One does this,
0.
one does this.
-2. Oh, we got 1.
And there's 2 Nash Equilibrium. So one is what? This one is going to be NB. And then that's one of them. That's this. Yeah. And the other one is NB. Okay. So what does this mean? We all know the weather. Okay. So if I tell you with sun, right? What are you going to do? If I just show you this game alone.
I mean, it's with perfect information.
Yeah, it's exactly. This is exactly. There's no complete information. It's perfect. Everything's perfect, right? And in fact, when you have perfect information, you might as well. There's no interaction between these two things, right? When it's sunny, we just do it. When it's rainy, so it's actually not that interesting in some sense. You just find the Nash Equilibrium here, and the Nash Equilibrium here. What is the Nash Equilibrium here? Yeah, and then it's actually dominance, right? When it's sunny, why don't you mean bell? You just get the one spin. So here's NN. So then we can go to Nash Equilibrium. This game alone is going to be NN. What about here? It's a Nash Equilibrium
And
here.
it'll be 2 here, right?
Yeah, exactly. I think
It's NB and NBN.
exactly. This is okay. Now, does this make sense given this?
Yeah.
Yeah, right. Because
Put them together.
exactly, you're just literally putting those things together, right? Exactly. It's not that deep. You're just saying that both people play N when it's sunny, no matter what. And depending on if we're in this Nash Equilibrium here, then that corresponds to this. Yes? This Nash Equilibrium corresponds to this. So this is kind of not super interesting because when everyone knows everything, again, there's no incomplete information. Everyone knows everything, so you don't have to do all this stuff in some sense. We could have just solved them separately. Okay? All right. So that's kind of fun. But now, let's now try to change the partitions around a little bit. How about, let's say that person one's partition looks like that, because they both don't know. Okay, how's the gate different? Yeah, exactly. All it changes is you just can't play BN and NB anymore, right? You just have two strategies, right? So my strategy is either NN. What's your strategies? It is a little distracting. Let's see if I can put this door. Okay. What goes in here? Do you have to compute it all over again?
Yeah.
Well, I'm lazy, so rather not write it. I mean, you could just literally look over there, right? I'll write it in the same order as everyone. I'll do BB. I'll make it easy. What is BB? What's here? Yeah, it's literally the corners of that thing over there, right? This is what? 0, 4. It's in here. Now what's the Nash equilibrium here? If you do this, my best response is 0, right? If you do this, my best response is -4. If I do this, your best response is 0. If I do this, best response is. So now this is interesting. This was kind of symmetrical. This is interesting. Now the only Nash equilibrium is what?
Is BBN.
See? Here, both people could have ended up bringing the umbrella. In this case, only one person bringing the umbrella. Why is that? Yeah, exactly. It's because it's -12. Person one is a lot more concerned. One has the suede jacket over there, right? Or one just got a pearl. Exactly. Right, so one, so in some sense, right, one kind of is stuck playing on the umbrella, right? But then why doesn't two? Okay, so one's stuck bringing it, and then two doesn't bring the umbrella because two knows that one's going to bring it. Essentially, right?
So they're the bad friend.
They're the bad friend. That's rational. Yeah, I'll totally. I know you're rain today. I know you have better clothes than I am, so therefore I'm not going to be able to go. But what's interesting is
some people think that.
what's interesting. Why is it so? Here you can kind of the person with the better clothes. You can make them kind of bring them out. Why does that not happen here? So this is the So here, the person wearing jeans or whatever with a bad haircut, what's the difference?
It's the relationship between the chaos for player 2, right? And
Exactly.
When player 1 doesn't bring the umbrella.
Right. It has to do with all these numbers and their relationship to each other. So it's this example is kind of carefully tuned. If this is a -12, what would happen over here? It clearly has to do with this -12 versus -16, right?
Then there would be two Nash.
Yeah, exactly. There would be another one, right? So we still have symmetry. Okay. The difference is in this -12 and -6. Okay. So if we're in this world alone, there is sort of symmetry. Even though the person has symmetry, we can still have a Nash equilibrium in which person 2 brings the umbrella. Why do we not have it over here? And it has to do with these precise numbers. Do you want to look at it? I'll think of it this way. Well, it's just, why is this, okay, so another way to think of it is like, so BB and N is a Nash equilibrium. Why is this not a Nash equilibrium? Why is not NN BB? What is this? This is the word in person 2. Why is this not a Nash equilibrium? Okay, here, this is a Nash equilibrium because person 1's having to pay the cost of bringing the umbrella all the time, right? That's the -4. If they didn't bring the umbrella, what would happen? They would get the -6. This -6 comes from what? The average of comes over here. 0 and minus 12, right? If no one's bringing the umbrella, then at the time it's 7, no problem, it's a 0. But if it's raining, then I get the minus 12, so that comes up to be a minus 6. So this is a Nash equilibrium because if I were to deviate, I'll get something worse. This is not a Nash equilibrium.
2 deviates.
Yeah, 2 is not deviating. But 2 instead of by deviating instead of a minus 6 gets a minus 3, right? Why? So what's the difference, right? If 2 deviates, 2, so this is where 2's bringing the umbrella all the time. If 2 deviates and never bring the umbrella, they will get the minus 6 half the time.
These days they don't care as much about it.
Exactly right. They don't care as much about being getting wet. The interesting thing is, if they knew for sure it's raining, then person 2 would also care. Right? Person 2 doesn't want to deviate from here to here. But if it's only 50% chance of raining, then person 2 says, oh, what the heck. See, that's the way it works. So that's why it's tuned. So if this minus 4 was like a minus 1, like there's low cost for them to bring them out, right, then we would we also have this Nash equilibrium. It's because minus 4 is bigger than half of minus. Minus 4 is worse than half of minus 6, but not worse than half of minus 12. So that's kind of the thing. Right? Makes sense? So person 2 is willing, person 2 would, if they know for sure it's going to rain, of course they would bring an umbrella. But if 50% they say, oh, what the heck, I'll willing to take my chances. Whereas person 1 doesn't want to take chances. That's interesting. Okay, so this is interesting. How about, let's do all the other ones. What about person 1 knows and person 2 doesn't know? Those again in the clip.
Player 1 can play the mix strategy.
Yeah.
Per se, that's an abusive terminology, but
Yeah, exactly.
Yeah.
Person 1 can play all these conditional strategies in here. Person 2, however, can only play BB and exactly right. So it's as if it's exactly the same as this, but this just doesn't, it goes away. That's all it is. So if I write that down again, I think if it loses you, it doesn't come back. Huh?
It's a good optimizer.
Exactly. It's not a global optimizer.
It feels melancholy.
Okay, now it's back. Okay. I think it sort of just gives up.
I think it goes to sleep.
Yeah. Okay. All right. So in this case, person 1 strategies are what? All 4, right? All 4. This dual one has 2. BB and
So
we just literally take the first and the last column, right? So that's
negative 4, negative 4, 0. Are you going down, negative 2?
oh, you're going
Negative 2.
Maybe you're negative 2, negative 4.
Right.
Sorry. Negative 2, negative 4.
Negative 2.
0, negative 4, 0. Negative 8, negative 3.
So negative
8.
Oh, okay.
Negative 2, 0. Negative 6, negative 2.
Right, so it's just simply, you don't have to really do all the work around. Let's do that. Maybe the best response here is what?
Is 0.
Best response here is. Best response here is 0. Best response here is 3. Best response here is. Is there a Nash equilibrium? No, it is.
Yep.
It's. This is where person 1 knows. Okay. Now, does person 1 like this better than this? I guess we can write down the payouts, right? This case is what? 0, 2, 0. This is what? BBNN runs this. 4, 0. This one was NBNN is what? Minus 2, 0. This is if you're person 1, do you prefer this or this? Yeah, this one, right? Because here, since you don't know, you'll be bringing the umbrella up on the side. Here, you're still stuck with an umbrella, at least you don't have to bring it inside. You only bring it inside. Okay. And finally, let's do the last one. The person who doesn't know.
So information is power.
Well, not necessarily.
If only you have it.
Well, hold on. Again, if you're person one, you prefer this over this. Clearly, you would want more information. Right?
Yeah.
So, but do you always want more information?
I'm not gonna make this stronger.
If you're two, you're worse off in the case that you know.
Yeah, exactly. If person two actually wants to not know. Right?
Well, they don't want person one to know, right?
Well, okay, we can figure out the entire. Yeah. But this,
We're about to figure.
we're about to figure out the entire thing exactly. We're about to figure. Exactly. That's a nice thing about this approach is you can share the things. Okay. So now person one only has two strategies, right? Okay, we're about to find out. That's why game theory is nice. Instead of like, just, oh, what can happen? You just make it like good math and just like to see it. You don't have to like, think about it.
Let's just make wild propositions.
Exactly. One way to think about it is like anytime you can make something just a matter of math, then you're kind of halfway there, right? Because once it's the math mode, like how bad could it be? Just try to get it out. That's kind of the entire point of it. All right.
So now it's just the top and the bottom.
Yeah, exactly. Right. So. What's this now?
-4, -2 for both.
This is
-6, -5, 0, -2.
okay. The best response here is 0. The best response here is 0. This is 0. The best response here is 2. So here the Nash Equilibrium is 2. This is going to correspond to 0 minus 2. The other one is this one up here. Okay, so let's finally ask the question. Of all these things, which is the best for person one? Maybe it's not as we can really skip. Because here person one gets either 0 or -4. Right? Here they get -2, here they get -4. Here they might get -2 or 0. Yeah. What do you think is kind of the best? Well, clearly there's one which is worst, I think, right? The worst, I think, for person one is this. Right? Because they get -4, they're stuck with bringing an umbrella, and they don't even, and they have bringing also even when it's sun. That's the worst thing. If you're, what's the best thing kind of go for? Maybe you that one over there? Or, yeah, full information, because they have either 0 or -2. Whereas here they get -4 for sure, here they get -2 for sure. There's not any chance of getting 0. And here they get 0 -4. So I think over there, yeah, they'd rather have everyone. Because basically then they can stick person 2 and sometimes bring an umbrella. They have a chance of doing that. Right. Okay, what about, so in that sense you need more information is good, right? Okay, now that I think about this. Conditional person 2 not knowing, would person 1 rather know or not know? They'd rather know because, yeah, they've got their -2. Conditional on person 2 knowing, would they rather know or not know? I guess they'd still rather know, I guess 0 and -2 versus 0 and -4. Right? You see them doing it? It's not very precise, right? I'm just saying. You think you get -2 or 0 over there. Okay, so person 1 always wants to know. If person 2 doesn't know, they want to know. Person 2 knows, they still know. How about person 2? What's the best thing for person 2 in all these things?
We have a lot of good options.
Yeah, exactly.
Oh,
These-
they do want to not know.
They do want to not know. Why? Oh, that's interesting. That's what this is why this is a fun exam. Yeah, the best thing is if they don't know. Right? Why is that?
Because there's Because then that makes it possible for them to not bring the umbrella
Yeah.
when it's sunny, right?
Exactly right. It's like saying, I don't know what sunny or rainy, and you know that I don't care enough about it to bring it if I don't know.
Yeah, because person one knows that they don't know.
Yeah.
Person one will bring the umbrella.
Yeah, exactly. Yeah.
They'll melt.
Yeah.
Technical question. Can you classify the Nash equilibrium there different than Nash equilibrium there, where it's the NN within the same partition?
Oh.
The-
That's a good question. Yeah. So strictly speaking, it is the same strategy, it's the same function, right?
Right, yeah.
So I'm just drawing it differently here, just to say, oh, this is kind of, I could have changed it, yeah, but this is the same strategy. Yes.
So, but would we consider that the same Nash equilibrium then?
Oh.
Or would those be like considered different?
I guess it is the same Nash Equilibrium, but well, strictly speaking, they're different games altogether. Right?
Okay.
We're in a different world, but yeah, but it is the same strategy. Yeah. Yeah. Okay. All right, so I'll go through the same thing. If person one doesn't know, would person two rather know or not know? So we're comparing this versus this. If person one doesn't know, and if they know, they get minus 2 or 0. If they don't know, they'd rather not know. Right? If person
two know.
yeah. So if person one doesn't know, person two rather not know. That's it. If person one knows, the person two, what would person two rather do? Not know, right? We get the 0 for sure because it's 0. And so person two all the time wants to not know. So it makes sense, right? It's like so not in other words, knowing is not always good, right? Person two wants to say so. Roommates get up in the morning. Or maybe I guess they live in different apartments, but they meet to take the bus or something down the block. Person A calls, person one says, I'd like to let you know that I have not listened to the weather report this morning. And I know you have really good clothes. Just letting you know that. So, so anyway, does it make sense? Kind of interesting, yeah. So I think, this is just an example, but there are situations which are like this. So already we have something non-trivial, which is like, we didn't model explicitly, but you can have a model game where people choose either or not. Right? There might be situations like, like diplomacy or like etiquette or something like that. I'd rather have not known if you told me that. Once you told me that you have equal weapons, now I have to do something about it. But if you didn't have never told me, then maybe you would have done that kind of thing. It's not okay.
So is it possible to assign probabilities to these different situations in terms of what is player one's, what does how likely does player one think that it is? What is player one's belief about the likelihood of player two having had the having?
Oh yeah.
Okay.
How would you model that? That's interesting. Okay, so here person one knows or not knows, right? So here there's just one thing, whether it's sunny or rainy. Could you basically kind of introduce another little bit of uncertainty, which is like, what's the likelihood that person two knows that one knows or something like that?
Right. And even just more broadly, there being uncertainty about which game you're
Right.
Exactly, yeah.
So how would you model that? So right now we just have the uncertainty about sun or rain. But if we want to add the uncertainty about what you know, what you know about the world, how would I add it in? So that
Is it uncertain about what the other person knows?
well, this is the kind of question you have to ask. So that's what you're talking about, right?
Yeah.
Person one doesn't know whether two knows.
Yeah.
Okay, how would I model that?
Oh,
Kind of, yeah, exactly, right?
We have to make a larger set of.
Yeah, exactly right. Now your omega is a little bigger.
an event that he.
Yeah, exactly right, exactly. Yeah, exactly. That's exactly right. So you might think this is a complicated thing, like some sort of thing. Oh my God, I'm thinking about this. How do they know it? But the way you do it is simply just go back to the omega, okay? And say the omega has to capture the uncertainty. So instead of how would I write that down? So right now we have sun and rain, right? Those are my two states, but maybe we'd have another kind of thing, which is like, I don't know, maybe like sun.
Player two knows.
Yeah, exactly. Right? Or I like to think about it as just some misogynist thing, like some like two, checks weather or something like that. Something like that. Okay, then so sun two checks weather, sun two doesn't. Rain two checks weather, and rain two doesn't. Okay. We're also assuming that these are things are not chosen by two,
Yeah.
okay, because then that adds a whole other little wrinkle. But we think that would be like the trees kind of thing. So we have 4 states. Let's think of it this way. Now let's see, how would this work? Actually, yeah, we kind of did this. So in this, now this is just one slight little step. You might even have more stuff like, oh, son 2 checks the weather, and person 1 knows that 2 checks the
Right,
weather.
right, right. In terms
Okay,
of
so-
the text messages.
Yeah, exactly. So you just add more states. That's what you do. Make these more stuff. But let's just stick with here now. What is person 1's Cartesian going to be? So that,
In which, sorry.
well, I guess it depends what say person 1 knows whether the weather is, but doesn't know whether 2 knows. For example.
Condition 1 would be sun 2, and the 2 sun 2, the 2 suns go with 2 checks and doesn't check.
Yeah,
Circle together.
exactly right. So person 1's person will know that person.
Yes.
Person 1 would know that some enough or not know. Yeah, exactly. What about person 2?
We assume they can distinguish between whether they check the weather.
Right,
It's
exactly.
not
Presumably,
even-
exactly.
so
They
they
know
know-
whether the difference to this and this.
I also look at 3,
Right.
say 2 checks,
Yeah.
2 checks, and then doesn't know as well.
Yeah, exactly right. If I check the weather, I can tell the difference between this and this. Yeah. So I think it's like this is kind of like the awake asleep thing. Right? If I'm awake, I know whether you're awake or asleep. But if I don't check, then these are in the same way. So it's
Yeah.
kind of like one side of this.
Right.
So what's nice about this is now you can just do the whole thing. So it's a little more complicated, but it's not that big a deal. Like you just kind of, and you have to assign probabilities to these things. And then you just do the whole thing. And then you could have a whole theory about that. Oh, you know, depending on how it is in the chaos. Sometimes maybe it makes a difference whether 1 knows that 2 checks the weather. Sometimes it makes a difference when 1 knows that 2 checks the weather, and sometimes it doesn't. Right? Makes sense? Right? So you could, I think, going back to the nuclear weapons things, I think once I talked to Barry for a second, the early days of nuclear weapons, it's like, you have this very, very extremely powerful weapon, but you're not sure whether the other person understands that, right? You don't know whether they understand it's powerful. You also don't know whether you understand that they understand. All these things, like it's just this new thing. How do you know it? So all that is modelable. You just write down this way, and you have to make assumptions, of course, but you can get an answer. So I think that's the answer. Anyway, going back to a simple example. What does incomplete information do? Remember I said that incomplete information is basically the same thing as incomplete. Incomplete information is the same thing as incomplete conditioning. The only difference in all these situations, they correspond to different information situations, is simply what things here you get rid of. Right? If I don't know anything, then this thing just becomes the corners and I get this basis. If 1 knows something, then 1 can condition it and 2 can't, so I just give it these middle things. Right? So there's nothing deep really here. All it is you have this is underlying game, and then you just erase some strategies. You just can't do the strategies which are conditioned on things you don't know about. The end. So when I first realized this, I realized, boy, I should wish you was talking to me that way. So that because when I was first talking to me, it was kind of in the 80s. It was like this is kind of a new thing. I thought this is so weird. But it really is just the simplest that. It just simply incomplete information is just incomplete conditioning. If you knew everything about the world, you could condition about everything in the world, there would be nothing interesting. It would just be a bunch of little games. Okay, if everyone knew everything, it would just be a bunch of little games. If no one knew anything, it would only just be one game where everything's just sort of smushed together. Like, just like, you see, this is just like the smushing of these 2 things. Right? It's just literally half of this plus half of this. Right? Because no one knows anything, so it might as well be. Right? You can't. The interesting thing is when somebody knows something and the person doesn't, then you think, oh, okay, well, that person has to condition, this person doesn't, but it's still just the same. It's just nothing fancy about it. Okay, so that's that. Okay, so
just a more like practical sense of like what one might do with some of these games. So let's say, for example, you're working in a somewhat more complicated game that we were just working on, and you like observe what looks like hand time or something like that, and like it conflicts. Again, this is not necessarily correct based on the model, but that it conflicts with your sort of like prediction based on the model, does that tell you that that your model is wrong if empirically observed sort of off, or do you just say that's off the equilibrium path and like,
Oh,
yeah,
or just saying, so say I make this model here, and I get a result which is different from what I see in the data or something.
exactly.
Right.
Let's say you test your model empirically in some setting that you think just makes sense.
Right, okay, so that is what people, that's like engaging in social science.
Yeah, right.
So,
but yeah, and I guess just the let's say you really care about your model like
Right.
this,
so, okay, so.
rather than just your theory about this particular context. Does that make sense?
No, of course. So there's, two directions you go. One is to say, okay, well, I have one colleague who is a famous economist, Robert Lucas, who said, don't let the data beat you up too much. What he said was, the basic idea is, you have some sort of explanation,
Sure.
and you find something which seems to contradict, don't just give it up, because maybe your explanation does really make sense. You just, there's something which is in the data which is not really corresponding to what you're talking about. So in other words, in general, when you come up, any explanation is never going to be right, in some sense, the first time. It'll always be caveats and, and always, but you kind of want to develop it, and hopefully it's going to go in the right direction. So if that happens, then of course, you see the data different from your model, you can say, oh, maybe my model's messed up. Maybe there's something which I can fix. And maybe if I can fix that, that's interesting. And or maybe I see someone else's model, I'll say, hey, that's supposed to apply, that person claims it applies to situation A, to the situation B, something very different, or sorry, very similar. Why doesn't it apply to situation B? Maybe it's because I need to change the model. The other thing you can say is, oh, maybe because I really believe in the logic of the model, and therefore I'm going to really interrogate the data and say, hey, maybe this data is not right, or like, well, maybe they made a mistake, or maybe like it was a bit measured a different way. Maybe the data is actually not quite exactly what's captured in the model. And you can also say something like, if I really am dedicated to my reasoning, then I'm going to collect the data, which will contradict this other data.
Sure.
Or maybe you can say something like that. Maybe I will like say my model only applies to certain things. So this kind of back and forth.
Yeah.
I mean.
Yeah, I realize the more generic sort of version of that question, which is fair, but yeah, it's yeah.
I mean, I think the reason why you modeled though in the first place is to kind of create a framework for that. So like if you didn't have a model at all, then you see the data and say, oh, okay, this goes up, but this goes down. That's the result. Yeah. But like, if you see that result not happening in some other case, you can simply say, oh, it happened in case country A, but not country B. But then if you have a model, you can say, why would it have to do that, right? Like I can build a model which shows why you have some difference. And I think that's a little bit better than simply saying, oh, it's different. And so that's kind of what the point of the model is, to make the reasoning very clear so you can kind of say why it works in some situations.
Sure. And I guess in the social sciences, you're almost always going to find some empirical case. Like you're always going to find some data that doesn't, that can like contradict your model.
I mean, I got to say too, like we're really concerned about validity. So it's something like, some people say, oh, I wrote this paper and I found that A causes B. And I say, well, did you expect that from the beginning? Like, isn't that just confirmation bias? Did you pre-register that idea that A causes B? And of course that makes sense, right? I mean, like, that's keeping me from like just doing a bunch of stuff with data and finding, say, oh, I found C causes D, but I really, was actually very possible. So that's true. But however, I think I'm a believer too much in sort of saying, like, well, I believe that if you have a strong theoretical idea, that's okay. And it's go get approach the idea with that idea and have a preconception. And we all have preconceptions. It's not like we're going into the world like not knowing anything or not having any idea. And so I think it's okay to have ideas and just sort of see. In other words, it's okay to be biased toward yourself to some degree. And of course you don't want to be crazy. Like there's some people who are like literally they believe in something their whole life and they just never move from it.
Well, I guess we just update, right?
Yeah, exactly.
Yeah.
But I think that otherwise, I don't know. It's like sometimes pretend that you're unbiased is the worst kind of bias, right? Presuming that we all can be unbiased, and we're approaching the world unbiasedly, that itself is a kind of arrogance. Does it make sense? I don't know.
It
Is
sounds
that fair?
bias, I'd say.
It's
Yeah.
Yeah,
That
exactly.
is a bias.
Yeah, I think the way, so I would put it as like self-awareness. That's kind of the ideal, right? I don't know how you put this. But I mean, is that too strong? Yeah, it is, I don't have anything with that, but I mean, I have colleagues who are very much validity, like you don't wanna like believe anything in some sense, or everything you do believe you should write down ahead of time, so. I just think it's.
From like what you've seen, what would you say is the biggest challenge when you're trying to model a real situation in this kind of way? Like for instance, like practically, you model something and you observe something different, and then you go back and check like what did I miss?
Right.
Like, is it? Because I can see not missing like the state of the world.
Right.
Or that being challenging to model,
Right.
or the payoffs.
Right.
You know, what would you say is like the hardest thing?
So most of my work has not been super applied like that. So I'm trying to think. I said it, but like most of my own stuff has been like saying, I think this can happen. I think this is a real thing. Like, I think like knowledge of other people's knowledge makes a difference. So these are common. But I don't think I've ever actually gone back and said I'm going to change the model because of this thing. So I'm not really on the ground like a lot of people are. Some people are very much like that. Like you might want to do that. If that's the case, then okay. So for example, just building this super simple model here, I built it because I wanted exactly to get this issue. I wanted to say, I want to show you in one simple model how sometimes it's good to have more information, sometimes bad. And so then I think, how could that work? I'll say, okay, I think this sort of scheme with an umbrella, blah, 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 blah. That's kind of how I came up with this. And so, if you're more on the ground saying, I want really to understand, really to explain this data I have, then you would have to do that. You would have to go back and forth and you would change all the things. But the other thing I'll say is that, okay, if I were in that situation, I guess I kind of have been in that situation. I would look at the data and I would be kind of not, this would not be statistically valid. I would do the following. I would just try to understand what the heck's going on in this situation. Like, you know, does the nuclear weapons make people more belligerent or something like that? I'm just going to try to find a pattern in the data. Then I'll say, what can explain that? Make the model which sort of gets at that. And then maybe test that with a little more data. That's kind of what I would do. Because the other thing about modeling is that it's not like, you can make it do anything you want. So you almost have to know what you want to get out of it to build it the way you want, right? So it could be something like, I see this weird thing, or even just literally one example, this weird example, I'm going to try to build a model which illustrates that example. Then you can say, oh, then I'll test it, kind of how it's done or something. But yeah, it's a challenge. I mean, but you know, that whole. So also, when I was trained, the purpose of most theorists were to say, oh, this could happen. This gives you well, this thing. But the kind of people saying, well, actually, have you tested this your exact model with real data? Most people didn't do that. That was kind of like the big divide between people who were modelers and testers. But now, people have a much higher expectation about that. They would like to say, so a lot of people have data analysis, models, the whole thing in one paper. And they're committed much more in a much more direct way. So if that's the case, then you'd want to make sure, you yourself, so back in the day, like when we were game theorists, you'd say, oh, if my model doesn't make sense, some empirical person will tell me. So, but if you are really committed to your data and you're hoping, then you're kind of doing all that within one person. I mean, you have to like change stuff, I guess. But that's what you want to do. I mean, ideally, you have new data. So the best thing is new data, new theory. Okay, so good.
Everything.
Everything you knew. Yeah, that's the ideal thing.
And no bias.
No. Yeah, so like, okay, so it used to be, somebody once told me, the main ways to make a contribution is either new data or new theory. New data, so sometimes if you have new data, it doesn't matter what your theory is, because it's just new. Like, this information has never been made to the world before, so you just simply talk about it. That's a contribution. And then you don't have to have anything new theory. You can say, well, my friends. Another thing is, you have new theory, you don't really have any data at all. And that's also cool. But now, like I say, you won't do everything. You do, new theory, new data. And of course, the third thing is like a new statistical method. So those are those three things. You could make your career just on one. You could do one right now. But some people try to do those things. That's just awesome. But again, like, going back to the thing which the collisional paper which I wrote, that was motivated by a kind of a practical problem really. So gonna go into it, like, so I motivated that problem because I was interested in like repression, like, why would you want to like, how do you gain by making a coalition not operate? Like, say you're a government or something. So, if you're making a government coalition not operate, how does it change the world, or how does it change the prediction? Okay, if you use the core, which was the common thing then, you have core. If you make a coalition not operate, what happens to the core? Just think of the definition. So remember, the core is a set of things which are not dominated, right? Like a majority rule situation. Say that I say that you're not a majority rule. You particular majority cannot operate. What happens to the core? So I suppress somebody. Does it change? It could change, right? But one way it'll never change. So the core will only get bigger, right? Anything which was not dominated before, you deactivate a coalition, that still will, you know, by deactivation, you make the core bigger, not smaller. Right? Does that make sense?
Yeah.
So anything which was not dominated before, you get when it's in coalition, it'll still be not dominated, right? So that's obviously not super interesting when you think about repression, right? Repression is all about trying to make something happen as opposed to like not, you know, you see what I'm saying? So therefore I thought, if I were to look at this problem, I've got to not use the core. And I'm like, oh, I've got to use something else. And then I went down this whole little path. I did go back and say, okay, now I'm going back into this model and then the Soviet, you know, Union 1989. I did not. But like, you know, but that's, you know, a lot of things are, you know, a lot of very, you know, I mean, just like we're talking about like a student or something, like the whole sampling distribution came out of a beer, you know, for beer or something. You know, it's, some things are very practical. So, you know, you might not close a circle, I guess, you know, I guess, maybe you would, I don't know, like, so Guinness would close a circle, like, no, this guy student could close a circle by like, I invented this technique, now I'm gonna make my own new beer factory or something, right? But I mean, you know. So as long as you're part of this process, you don't have to do everything yourself, I guess. You know. If your theoretical idea is so striking that people go, wow, they're not gonna say, oh, where's the confirmation? You know? But if it's not super striking, they might say, oh, where's the confirmation? You know, so it all depends on what you do. You might have a really cool empirical thing, and you might say, I don't know what causes this, and then people say, that's enough, that's okay. It's just so great that you have this find this new empirical thing. But if it's only a small thing, people say, well, what caused that? You know, be clear enough of what causes it, and what's the mechanism. And so all these things. But definitely the standards are higher, so you have it harder than people like in my generation. Yeah, good luck. No, I mean,
Higher quality.
well, I mean, that's how, what I always say is like, you know, standards of research and standards of everything progress, so we just require a lot more of each other, but it makes it harder at the same time. It's much better to be in that situation than if it got worse. Imagine like, it would be okay if your dissertation was like worse than, you know, same thing, so.
As long as the expectations of empirical testing don't place downward pressure on kind of the models that people are willing to entertain, right? It's like,
Yeah.
as long as you're not expected to prove your model, because you can still get interesting, like,
Yeah.
theoretical possibilities. I guess that's one question I have too, is like, if you do, like, how do you know that something is, if some empirical abnormality or whatever is an indication of something being wrong in your model, or just like irrational behavior in the way that we think about like behavioral economics or whatever.
Right.
Is that something that there might be like a useful paper on, or like
Sure. So,
a term for that? Yeah.
I mean, yeah, so like, say that your model is not confirmed with something data. So say my model says if A goes up, B goes up.
Right.
And my data, I found that if A goes up, it goes down.
Right.
What do? I can say, okay, I'm gonna fix my model in a certain way, and maybe there's some factors I've not, which I should put in there. But another thing you could say is, well, this whole idea of modeling just doesn't make sense. Like the whole underlying premise, maybe it's completely different mechanism, some sort of psychological thing, or some sort of drive-based thing, and then you might be forced to move in that direction if you really, So, you know,
Can you just kind of, how do you go about, I mean, the how is context dependent, obviously, I guess, so you try to make sense of what you're seeing, but.
well, I mean, I have seen talks which go like this, like, I built this model which if it increases, B also increases, but I did not find that in the data. So then I made another model. It doesn't explain it. So maybe because this other model emphasizes the factor C. But I put C in the regressions, that's, you know, that doesn't make a difference either. I'll say, well, I'll do the other thing. So I have seen talks like that, and that also that's kind of cool too. Because, I mean, you see papers like that too sometimes. Like I see this effect. I'll try to like test all these different possible things I can think of, which explains that, and I don't really get a good result. That's okay. I mean, that's kind of interesting. If those things are credible, like if you're not just sort of pulling out of nowhere, like those things are all reasonable. And then you could say at the end is like, I tried all these different things, and that really makes any sense. Maybe we need to do the following. I've given up. Maybe you should do it. That's okay. I mean, it's more. It'd be nice to say, I did find it in the end.
Yeah.
I don't know. It's hard to say, but
I'll try to bring a specific.
no, yeah, we could talk about
yeah.
it. Yeah. I mean, I do feel like it is harder, and like I'm just used to like looking at data saying, hey, that goes up. Like I'm a soaker and poker. I'm totally okay to just look at stuff. I think that's okay. Whereas now we're thinking like, oh, you have to approach everything in a completely unbiased way, which I don't know. I mean, but I understand that too because it's clear that those sorts of confirmation biases and so on. But I kind of agree that there's a pendulum kind of. I mean, when I was in graduate school, in the econ, theory was really seen as really driving everything.
Yeah.
But now in econ as well as political science, it's now
Metrics.
yeah, it's like all about metrics kind of. It's all about data. Like it's hard now to write a paper which just doesn't have data in it, which is understandable. It's just a nonsense, I think. The reason why theory was modeling was value is because we just didn't have the kind of data we have now. Maybe if we always had that kind of data, we would never even gone down that path. But then sometimes I think, well, the wisdom is not just like one huge regression. It's not like if I could just find all the ways A can cause B, which causes C, and all that. If I literally knew all those things with perfect statistical precision, I still might not know what the world is about in some sense, And what the world is about is like identifying these mechanisms, having some sort of general kind of explanation. So, I don't know.
Everything and nothing.
Yeah, you're more skeptical of it. I don't know.
No, I mean, I agree.
Yeah.
A lot of theories that explain everything.
Yeah.
They really explain nothing.
Yeah. I don't know. It's hard to say. It's all. I see now like a lot of people who do this validity stuff as younger than me, so I don't want to like rain on the parade because people totally rained on my parade back then. So I don't want to like say, oh, but everyone is a different. You do really see, generational shifts and all that. So. We'll see. Hopefully there's room for all of us. Hopefully they'll come up with an interesting idea. You'll find great data, great new model, new statistical technique, no problem, everything's fine.
What's like some compelling, like more recent stuff that you find like or the field? I don't know to the extent that you feel comfortable speaking for other people or for yourself. Like what could we look to as like model stuff?
Model.
That's good things.
Yeah.
I don't know. It's a good question.
Yeah. Or is it all just hogwash?
No, like I remember once on this, there's this famous paper on bed nets, on whether that is that by Kramer or there's this RCT stuff on like if you give people not the mosquito nets.
Oh sure, yeah.
Yeah, and how much that affects them. Like, is that better to give them mosquito nets or to give them vitamins or something like that? There's papers like that, and those people made people in economics famous, and some people like do energy, do flow, that kind of stuff, and some of my econ theory friends are saying, is that economics? Like, now we know that bed nets are good, okay, but like, does that apply to other things, So I do see, I mean, it's a little bit strong, so I think it's interesting to see whether bed nets help you or something, but another famous is Steve Levitt type stuff.
Sure.
Did changing abortion laws in one state make, change crime rates or whatever like that. That's interesting. But I kind of agree that the comparative advantage of modern social science is delineating mechanisms and not just detecting empirical phenomena. So, obviously we now have this huge setup in statistics to predict empirical phenomena, which is amazing and great, and we do that all the time. It's awesome that exists. But you could be a statistician and not know anything about where people work or something and still find those things, Like, there's a reason why, sometimes, so what we're better at is kind of like saying, okay, well, I see this empirical thing, what could cause it? And I'm aware of several mechanisms which might be candidates. That's kind of, I think, what we come up to. Like if I think I can come up with a new, so I once had this argument with my son. He said, like, if A causes B, there's not like we have a dearth of theories which it's like, why A would cause B, right? We have many theories. So the issue really is figuring out which theory is correct.
Sure.
And then what I always say, so this is a classic empirical versus theory. It's like, you don't have an idea in your mind what's causing this, you're not even going to know what to look for in some sense, right? Right, so I don't know. So he's all about the data, like, I will sometimes say to him something, I think this could happen, he said, that's an N equals one kind of observation. But I said, I'm okay, that's what I'm supposed to do. I'm a theorist, that's how I'm okay with that. I'm just saying, this is interesting to me. But I don't know.
I mean, it's N is greater than or equal to 1, right? Like it could be more than.
Yeah,
Yeah.
exactly. But I'm totally willing to, I'm going to say, like, I see something in the street and say, that person's wearing a hat. Why is that? There's an explanation for that, as opposed to look at thousands of people,
Sure.
But I think and if somebody has to be willing to look out for new mechanisms. That's all I'm saying. That has to be part of it. Somebody has to be thinking about that, because. And I believe in it. I believe that we do understand certain things better because we look at these things. Like this common knowledge stuff. Like, before I wrote this stuff, when I first presented this stuff, people just thought this was a joke. Like they said, how could this, I presented some of this stuff and said, this is a way of explaining rituals. Like in a ritual, you see the Super Bowl, I see it, and I know that you know it, that kind of thing. And some people, economists would say, what is that? Like, is this some psychological thing, whatever thing, And so I just had to come up with the evidence I had, and I think now people are getting used to the idea. But like, so at least in my mind, I understand these things a little better. I don't know about you, but like, so, before that, I understood worse. So I think that's, whether it actually, I could present regression, maybe I hope we can. And some people are using that in regression. Like, there's some people who look at like whether people will adapt to a new norm and whether that affects by whether they, like they'll play like, there's one person Eric Arias, who did this studying whether people will agree with the statement like, violence has no place in a home. And so there was a UN thing where they played a radio show in which like domestic violence was was condemned in this radio show. It was like so obviously important to get rid of, stop domestic violence. Anyway, so what Eric Arias did was he in some village in Mexico, this was broadcast. In some areas, it was so mountainous, it was clear that if you heard it, you didn't think anyone else heard it. In some areas, it was kind of in the town, you heard it was pretty clear that people heard it. And you found a difference. In other words, it wasn't just you hearing the message, it was whether you perceived other people hearing it. So, and now it is an regression, So like you could come up with some crazy little idea. 20 or 30 years later, people say, oh, okay, maybe I'll put my regression. I say this all the time, like, now we're really going up, but I mean like, GMP, you put that in regression. We don't think that's a crazy thing to do is put GMP in regression, but when you think about it, it's really a very crazy thing, right? We're going to say everything the country does economically, we're going to put into one number. What does that even mean? Like, and so one of my economics professors, he passed away, he spent his whole life, early part of his life, defining what GMP was. You think, that's trivial, right? That's just a descriptive exercise. But actually it was not, because they had to make all these decisions like, what do people do work which is not paid? And this is, it's like women's child care, taking care of kids. Is that part of GMP? Well, it's pretty productive, right? It's obviously important for the economy. Why? So it's not, they made a decision, this is not going to be GMP. What about service industries? Like, so all these things, they have an impact, right? If women's work or child care work wasn't GMP, we might measure things in a different way. So it's virtually quite non-trivial even to just define what GMP is. But now once you do it, people just throw it in there. But in some sense, that's kind of means that you succeeded. Right? Once you have an idea, some theoretical idea, you develop it, and people just say, okay, fine. That means you kind of, it's been accepted for better or worse. Look at that. We can talk more about that. I think next time we'll do more examples at Thanks.
Sure, our meeting popped up at 1 p.m. tomorrow, so I don't know if you want to meet at